Alright, this video will explain you the steps on creating a staircase or the design of vase slab and staircase. Alright, okay, so first let's draw the asset here. Alright, okay, in the top view, the stair has having a width of 1 meter. And the top view, I'm having a flight having 3 meter. 3 meter is the flight, or you could say that would be the total going of the flight. Then I'm having the landing width shall be 1.25 meter. Okay, and the gap between two flight will be, I think they can be maybe well, they could be like 0.2 meter. Alright, floor to floor height shall be 3 meter. Alright, okay, so first let's draw this asset. Alright, we have floor to floor height shall be can be like 3 meter. So this landing slabs will be right at the height of 1.5 meter. So let's draw it. First, using up the grid, beam grid, I'm gonna insert a single node right here. Then I'm gonna be using a node cursor for selecting and translating this right into 1 meter, which could be the width of the stair, or I can use, just enable the grid. You can click up these 2 points here. Alright, okay, so we got the beam right there. I'm sorry for double clicking. Then I like to copy paste. Again, how right click, I can copy, right click, paste beam. Alright, this one. Right now we have a beam right here, and I would like to translate this beam into the negative z direction, Alright, right into the y direction shall be the floor to floor height, or the height of the landing slab, which comes to be 1.5 meter. And if you observe that the z-axis shall be negative, this should be negative 3 meter. So just observe this number, just hit OK. Analyze why did I pick two numbers like this. I know that the floor to floor height shall be, the orientation x is to this direction, z is to this direction. Okay, so from here, in order to reach this point, I have to move 3 meter in the negative z direction, and height shall be 1.5 meter. So that's the reason why I've given that number 1.5 and 3 in the corresponding x and negative z direction. Alright, we're left up with the beam right here. Now I'd like to translate these nodes right into this point. This shall be right 1.25 meter, right into negative z direction. So using the node cursor, I can select the asset, and I like to translate and repeat right into the z direction. The value shall be negative 1.25 meter. And okay, I'm having a sort of node here. Next, we'll like to translate this node right into the other direction. It could be like 2.2 meter, 1 meter, 0.2 meter, and again 1 meter. So this could be like translating the asset 2.2 meter in the positive x direction. Then I'll like to link the step, as I like to show up the beam connecting these points. Alright, then I would like to translate this particular node into the other direction, same as that of this distance. It could be like a translate repeat. Then I can have the z, it could be like 1.25 meter. Then I like to link the step. Alright, we got the asset right here. Then I like to again translate this right into negative x direction. Alright, I can link the step, hit OK. Alright, finally I like to copy this asset, which is already here, right into this space with the distance in z as 3 meter, and the height shall be 1.5 meter. So right click, I can copy, then paste beam. This one shall be 1.5 meter as the floor to floor height from landing to the first floor will be 1.5 meter, and the flight length shall be 3 meters. So that's it. Alright, okay, cool. Then what we want to do here is we like to insert a plate right on here. Alright, for inserting plate, I like to take up the add plate option, and come on here, man. Add plate. Use these 4 nodes here: first, second, third, and fourth. Okay, then another node right here: first, second, third, and fourth. One more here: first, second, third, and fourth. Alright, that's clear. Okay, so we got something like this. Then I like to select all these plates. You know, I'm not really interested in meshing the plate with beams nearby the structure. Actually, that will create all the messing with the beams, okay? As the plate get meshed, nearby beams will also get meshed. That will eventually produce a wrong result in the design of beam, or else you want to use the concrete design tab for converting this right into the physical member right there. Okay, those and all are optional. Right now I'm gonna select the beam. Alright, okay, I like to select all the plates. Then I'll like to convert. Right click, mesh it. Okay, 10 divisions, and I can have the polygonal or quadrilateral meshing. Really doesn't matter. Alright, that looks so cool. The worst part of this case is, you know, if you select the asset, this is a beam. Made another video and all the problems in design of slab in STAAD PRO. Just watch it. This is not a preferred method, okay? So, first you have to understand that we'll be having beams right here. Okay, so we'll be having beams just getting to the top view. Alright, there won't be any sort of beams right here, so I can delete the beams right here. Okay, deleted. No beams right on to this face. No beams right on to this face. Okay, these beams are optional. Okay, just before that, deleted. There won't be any beams right into these faces. Okay, that's the basic rule. If you've been inside, if you went to any sort of construction site, you might able to see this. What am I saying? Okay, I'm not considering any sort of design of beam right here. I'm only considering design of slabs here, so I can delete all these beams, which is unnecessary application of materials right there. Next, I like to get the thickness of the plate. It can be like 12 centimeter for the first iteration. What? Right, then I like to assign this right into the view. Okay, so the thickness got assigned. Then I like to add some sort of supports here. Okay, first you have to understand that you have to pick up the support wherever you will see the beams here. Okay, we'll be having beams right here. Hold on control. We'll be having beams right here in the starting and at the ending of the flight. Also, we would like to assign supports right into the faces where the meshing orientation changes. Right, this face, the meshing changes. Will be more rectangular, and this will be more, I can say, square. So I'll be picking up this pace right here. Then I like to assign a sort of fixed support right here. I'm not interested in providing supports right into this face, as this one is just like a one-way slab. Alright, this totally depends on your design requirement. I've seen a lot of structural engineers providing beams right into this face, which is optional, as most of the load from the structure will be distributed right into this longer direction. That's just to say one-way slab. So I don't recommend you to provide a sort of beams right into this face, okay, or supports right into this face. Right, that's cool. Then I like to get into loading. I'll be creating a new load case named as dead load. Then next one will be a live load. Alright, okay, I've opened a sort of slideshow that might give you something relating with the stairs. Alright, okay, so the first thing is Alright, we consider the live load on the stairs. If there is no overcrowd, we'll be providing 3 kilonewton per meter square. And if the case comes to be the overcrowded stairs, they could be like 5 kilonewton per meter square. This could be like a fire stair. Fire stair always carry 5 kilonewton per meter square. Alright, then we consider the dead load of the waste slab. Okay, just assume that the stair will be something like this. We got a waste slab and we'll be having some sort of steps here. I'm sorry. Okay, consider here. Alright, we'll be having a sort of waste slab here, having a sort of reinforcement. Then on top of waste slab, we'll be having steps which doesn't have any sort of reinforcement. Alright, okay, the waste slab will be calculated by the software. The STAAD will calculate the self-weight of the waste slab, then assign it right into the structure, okay? Or you can use the manual formula for this. I don't recommend using manual formula as you got the self-weight here. Then the dead load of steps will be considered to be 12.5 R. R is the riser height. It's much height, okay, Newton per meter square. Okay, then we can have, alright, if that a number, the riser comes to be 15 centimeter, the value that comes to be approximately 1.875 kilonewton per meter square. This one will be the dead load of steps. Right, so let's incorporate all these load cases right into ETABS. Right in the dead load, I'm having a sort of self-weight here, okay, self-weight. Then I'll be having a plate load right in the global y direction. Plate load shall be the dead load of the steps. It could be like 1.875. This will be the dead load of the steps. Alright, then comes the live load. I'm assuming that I'm designing a normal type of stair, not the fire stair. So I can give -3 in the global y direction. Alright, okay, let's assign this all. Assign to view. Alright, this number, the plate load that shall be coming right into the steps. So assign to selected plates. There won't be any sort of steps right at the landing, so I had omitted it. Now next is the plate load. Alright, okay, so assign it to the view. Alright, I would like to add some sort of combinations, auto load combinations from IS. Alright, okay, so picking up IS456 table, then I like to generate load cases. Alright, okay, so these are the load cases, and I like to analyze the structure, then run the analysis. Important things, either no errors in warning, which is not a big deal. The primary thing that we would like to check is, okay, you can say that should be the plate stress. Plate stress comes to be the maximum absolute. Those numbers could be trans-checked from IS456. I don't remember. I don't remember. That should be table 7.3. This is the critical value for shear stress. If I am supposed to use M25, I won't expect the shear stress to be greater than 3.1 Newton per mm square. Just let's get into here. Maximum absolute is 2.8, so I can use M25 without any struggle. Alright, if I'm using M20, I can have the stress values up to 2.8, which is a failure. Okay, I can adjust this by simply getting into the model space. Okay, just leave it. Okay, cancel it. I can get into analytical model and increase the thickness of the plate so that I can either use M20, which could be the lower grade concrete, That's it. So the important thing is the plate stress. As else, checking up everything. It can be like can be plate stress. Again, I trade. It could be like 1.5 dead. Like okay, 2.25. 2.25 was just the same thing. 1.5 dead. Right, so that's the analysis and the check for the adequate shear stress. Adequate shear stress. Now the design of this asset. It comes to be just getting the analytical model here. I can design. It's just like a concrete thing. Concrete. A slab. I just select the parameter. I'm picking up maybe the grade of the concrete, just only the grade and stress and Fy for rebar. Alright, and like to define parameters. I'm not really a fan of using kilonewton per meter square as the base value. Okay, 25000. Alright, I'm not really interested in providing the converted unit, as I'm interested in using get into geometry. I like to change up the units right into Newton millimeter, Newton mm. Okay, apply it in design. Okay, I'm just getting to design and define the parameters. I don't want, oh sorry, just get into concrete. Define the parameters. Oh my god, I don't want to have the whole parameters right on this stage. Just only FC, Fy main, just that's enough, and define the parameters. It could be like 25, add it. The Fy main shall be like to have 4 and 5. Alright, okay, so commands and design the slab here. Okay, then assign this whole asset to the view. Assign it to the view. Okay, cool. Next. Alright, cool. Next. That's it. Next option, I can go for, well, run the analysis. Alright, okay, so I can have the output file. I'm having, taking up the output file. I'm having a sort of reinforcement right in the longitudinal direction and transverse direction. The area of steel is represented in mm square per meter. The value, the answer is 120. I'll tell you what that number is. Alright, okay, so this one is the longitudinal direction and this one is the transverse direction. So the number in the longitudinal direction is 120 mm square per meter. So what I'm gonna do here is 120 mm square is the area of steel here. So 120 is equal to number into pi d square by 4. So either you can assume some sort of number or you can assume a sort of diameter. So maybe I'm getting the number as 3 numbers having maybe 12 mm diameter bar. So how am I able to distribute this right into the slab is per meter, which means I'm taking 1 meter right in the longitudinal direction, which one is perpendicular to longitudinal direction, and I can lay the 3 bars right here. The spacing will be 1 by 3 and 1 by 3. Okay, the spacing shall be 1 by 3 right in each faces, 1 by 3 from each faces. So together that will cover 1 meter. Okay, this one is the basic distribution of area of steel. So one thing I would like to say is it could be like a sad story in STAAD PRO. This is a plate number 12. Design is exclusively for plate number 12 here. If I try to close it, and I'd like to know what is plate number 12 here. So I'd like to double click this asset here. understand the length of the plate, which is 335 millimeter, which is very small, and this one is 100 millimeter or 10 centimeter. You're getting a dairy milk or a Milky Bar piece of slab right here. So for this we have to lay that much a diameter bar here. Okay, this is not my fault. As you can see, the basic concept of FEM is meshing. If I mesh the slab, if I didn't mesh the slab, I'm not getting any sort of accurate results for design of slab. If I meshed it, I'm getting some sort of errors or some sort of crazy design in the area of steel of slab. So what we usually do is we don't design slab using STAAD PRO. All we'll do here is let's get into post-processing and find out whether the stress in plate is adequate to provide the thickness for the slab here. Was what we do in the software STAAD PRO, not design of plate. The design of slab is a total maniac and no one's going to follow that, okay? So that's a sad story in design of staircase in STAAD PRO. They say thanks for watching.